We're going to be doing section 6.1, which is law of sines. We're going to have an oblique triangle today, so not right triangles. And to solve an oblique triangle, you need to know the measure of at least one side and the measure of any two other parts, 1 of 4. When we had a right triangle, we could use SOHCAHTOA, and for oblique triangles, we have to use either law of sines or law of cosines. There are 4 situations when you have one side and 2 other parts. The first one would be 2 angles, oops, and a side. This situation could be either angle, angle, side, or angle, side, angle. You could have 2 sides and an opposite angle. Which is side, side angle. Could have 3 sides. Or you could have 2 sides and their included angle. Which is side, angle, side. For the law of sines, it is a side A over the sine of that angle A. Angle A would be across from side A. And it works with all the pairs. And you could also flip it over. You could have this angle on top over the side as well. I just say do it however is most convenient for what you're trying to solve for. So here we have, I always like to draw a picture. So we have 2 angles and a side. This is angle C, which is 102.3 degrees. This angle B is over here, 28.7 degrees. We don't know angle A. Side B is 27.4, and we don't know side C or side A. So the first thing that you want to do is solve for the unknown angle if you have 2 angles already. A, well, I guess we don't need the degrees there. Angle A is 180 minus the 2 angles I already have. So that's 49 degrees. Now I have the pair of the 2 B's. So if I'm trying to solve for a side, I generally want to put the side on top. So side B, 27.4, divided by the sine of angle B, 28.7, equals, let's go with the angle that we knew first, so side C over sine of 102.3. If I go through and solve for side C, I would get about 55.75, and this is in feet. And then we need to find side A. So I'm going to use the same pair, the original pair, in case we made a mistake in our calculation for C. I don't want to use that one. Side A over sine of 49, and side A is about 43.06 feet. Okay, so we're always finding 3 measurements. A pole tilts toward the sun. So here's our, let's make that dotted. Our vertical is dotted. We have a pole tilting toward the sun. Here's our pole. An 8-degree angle. And it casts a 22-foot shadow. Obviously the shadow would be away from the sun. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? Okay, so we have a pair. We always need a pair with law of sines. Our pair is the 8 degrees, oh, I'm sorry. I guess we don't, that always looked like that angle was on top. It is not. So undo that. There we go. This angle down here is 90 plus 8, so 98. So we need to find this angle up here. Let's call it B. I need to find angle B so that I have that pair with the 22. So my angle B is 39 degrees. That's better. So now I can set up the pair with the 22 and the 39 to find the length of A. And I would always cross multiply to solve these. About 23.84 feet is how tall the pole is. Okay, so we have an ambiguous case. That's what it's called. It is side-side angle. With a side-side angle, that's when you are given two sides. Let's call them A and B, and an angle A. Okay, so it's one of the angles right across from one of our sides. There are 6 different situations you could have with the ambiguous case, and I'm going to illustrate all of them for you now. So if my side A, which is across from angle A, if that is less than the height of the triangle, then we're going to have, it's going to be no solution. These are all with an acute angle. We'll do those first. A is equal to the height, then it's a right triangle. There is one solution. Another acute angle here. If A is greater than H, then we have one solution. And the last acute situation. Okay, so what if our side A was between the height and our side B? I drew 2 different situations there. We have 2 solutions. Your angle, or I'm sorry, your side could either be inside the height, which this is inside, or outside the height. So we have 2 different triangles, so we need to find both solutions with those cases. And then when we have an obtuse, angle A is obtuse. If side A, that's terrible, but if side A is less than or equal to side B, then this is a no solution. But if side A is bigger than side B, we have one solution. Now I talked about height a little bit. So I drew in the heights on some of those triangles. The way we find the height is right here. So we're going to be given 2 sides and an angle. You're going to use the side that does not match your angle. So it's not always going to be A, B, and A. So just be careful with that. If you are going to take the side that's not in the pair, and you're going to multiply it by the sine of the angle that is in the pair, and that will give you the H. All right, so we're going to have to figure out SSA. Have to figure out what our how many solutions we have. So here we have a triangle where A is 22 inches, B is 12 inches, and A is 42 degrees. So this is one of the acute situations. Find the remaining sides and angles. So we need to find side C and then the remaining two angles. So just to find the remaining two angles, well, before I start, I think that I'm going to calculate H to see if this is a 1 or 2 or no solution. H is B sine of A. Which is 8.03 about. Okay, so comparing, our A is definitely bigger than H, which means, and it's not less than B. A is not less than B. So we're good with one solution. So we're going to use law of sines then to figure out our pairs. Just go ahead and do that. Let's find angle B first. Sine of angle B over 12 equals our pair, sine of 42 over 22. Cross multiply, you'll have to take the inverse sine of your answer, and you'll get about 21, not 12. Thinking backwards. 21.41 degrees for angle B. And then I can subtract from 180 to find angle C. So 116.59 for angle C. And then I can finally find side C with our pair. Side C is about 29.4 inches. There's our three answers. No solution case. I'm going to calculate my H first. My H is 24.9. And if I'm looking at my chart on the previous page to compare the H to everything, it looks like my A is less than H, which it is. 15 is less than 24.95. So it's no solution. I don't even have to go through and find everything. If you tried to go through and find everything, one of your angles wouldn't work. So then you would know it's no solution. Okay, I think the trickiest kind of case is this two solution case. So we'll work through this nice and slow. Find two triangles for which A is 12, B is 31, and A is 20.5 degrees. So I'm going to know for a fact that this is two solution by finding my H. Which is 10.86. My height, 10.86, is less than A, which is less than B. So I know that we have two solutions. Okay, I'm going to find my angle B, which I'm always going to find the angle that matches with the other side that I have. So I'm going to find angle B first, always. There's nothing else you can do. So that's what you're going to do. Find B. This is going to be B1 because remember we're going to have two solutions here. And I will get my B1 to be 64.8 degrees. I'm going to split this screen into two sides here. I'm going to keep my triangle 1 on the left side. I'm going to have triangle 2, so triangle 1, triangle 2 on the right side. To find my second angle B, which would be B2, this is always what you're going to do. Once you find your angle B1, you're going to take 180 and subtract it. That's going to be your B2. So 115.2 is your B2. Now you're going to finish both triangles independently. I think I'm going to stick with the left side first and finish that triangle and go back to finish the second one to find the remaining two pieces, we need another angle on another side. So I'm going to find angle C1 over here first, which is 180 minus our 2 existing. Our 2 existing is 20.5 and 64.8. And then side C1. Okay, so these are very independent of one another. Once you find that B2, you do not need to compare them anymore. Okay, I have B2, and then I'm going to find C2, angle C2, 180 minus 20.5 minus 115.2 is 44.3. And I'll find my side C2. My side C2 is 23.93 meters. Okay, so it's tricky to set up right away, but once you understand the process of setting that up, it's really not challenging. Okay, an area of an oblique triangle, you're going to be given 2 sides and an angle which doesn't match either of those sides. If you have that situation, then you know this is the equation you're going to use. 1/2 times both sides times the sine of the angle that you were given. So area is 1/2 both sides times the angle you were given. That's it. We have one more problem on the next page. We have a course for a boat race starting at point A. Proceeds directly south. I'm sorry, starts in the direction south 52 west, which would be over here, 52 degrees off of south, to point B, and in the direction south 40 degrees east. So remembering all of our bearings, 40 degrees is off of south towards east to point C and back to A. Point C lies 8 kilometers directly south of A. Approximate the total distance of the course. So I'm recognizing first, before I do anything, I'm recognizing that I have vertical, or I have a transversal. My side AC and this horizontal under here for B, those are parallel, meaning this 40-degree angle is actually our angle C. So I can find angle B by subtracting my other 2 angles. Okay, so this should be 88 degrees. Now my pictures are never to scale. And then I need to find side A and side C. Let's just start with side A. .308, and side C is 5.145, and the approximate, and what we're trying to do is find the length of the whole course. So we add all 3 sides together. And I get 19.453 kilometers total for our race course. And that gives us section 1 on the law of sines.